Our bodies are built as astonishing hierarchies of complex structures. We consist of different types of cells, each performing specialized tasks. These cells are composed of intricate nanomachines, long chains of molecules that carry out the essential functions of life. Molecules themselves are built from atoms, which in turn are made up of nuclei and electrons. The nuclei consist of protons and neutrons, and these particles are composed of even smaller components, quarks and gluons. If you zoom in far enough, we appear like skyscrapers stretching from Earth to the moon, vast, complex, connected structures with motion inside. They perform sophisticated tasks and are so intricate that even the components inside your smartphone pale in comparison. But unlike real skyscrapers, the building blocks of our bodies aren't physically attached to one another. They float, held together by repelling and attracting forces. They hover in empty space, bound together by invisible fields. The distances between these construction parts of matter, particles, are so immense relative to their size that one could say we are mostly empty space. So what holds this intricate hierarchy of structures together? Why doesn't it all collapse? We now know the answer. Even if you removed every material element, every atom, every molecule, the space our bodies occupy wouldn't be truly empty. What remains are the fields, the quantum fields. They do not require matter or any elementary particles to exist. They are simply there. But are they real? Not in the usual sense. Consider music. It isn't something physically tangible, yet we can experience it. In that way, quantum fields are similar. They aren't real in the classical sense, but we consider them real because they exhibit measurable properties. These properties reveal themselves when we probe the fields using particles. Even in a perfect vacuum, the quantum fields are never truly still. They constantly fluctuate. They vibrate with various frequencies. They produce virtual particles that briefly appear and then vanish, a restless dance at the heart of what we call empty space, with the energy of a boiling vacuum. Here is a simple analogy. Leave your computer unattended, and eventually the screen will switch to screensaver mode. It will go dark. It may look like nothing is happening, but in reality, the screen is still active. Each pixel is still being refreshed, still flickering, just enough to produce a black image. The screen remains warm to the touch because the pixels are still working, even without showing any image. Our bodies, made of floating parts, each animated to perform a certain function and separated by immense distances relative to their size, rest on the very unlikely foundation: quantum fields. They are constantly fluctuating, seething with energy, and never truly at rest. It's hard to imagine building anything stable on such a restless foundation. It would be like constructing a skyscraper on the surface of a stormy ocean. And yet, you are here. But why? If you already know the answer rooted in your own life, ask something else. Could this perceived complexity of unlikely parts connected by invisible fields that shape our world be an illusion of something entirely different? When a computer character on the screen tries to uncover the origin of all things around, he discovers pixels. These pixels flicker in a certain order, creating an illusion perceived by the inhabitants of the game as being particles affected by invisible forces, or by fields that repel and bind pixels together to form the simulated world. He may discover something that can be called quantum fields. Offering a proper explanation may require going beyond the flickering pixels of a computer screen and turning to concepts that lie well beyond our everyday perception of the material world. But are you ready for this?